So containerization, okay, you know that these days most of the applications are getting created as a microservice. So I'll explain what exactly microservice is and how the DevOps has changed. The DevOps framework has changed the way of deploying application. Nowadays customers want to make the changes in a very agile way. They want to have all the new updates or new version of their application to be available immediately to the business, or else that particular feature might be made available by their competitor. So nowadays any industry you take, they want to have a very agile process. Either the way they come up with new features or new version of their application, they want to get it deployed the same day, or at least in the next couple of days. So now the containers, which is what we generally use in the modern application, it's a kind of software package that we create just with what the application needs to run. See, earlier, maybe 25 years back, when we did not have this virtualization, or we did not have much usage of your virtualization, we were having different situation, different scenario at that time. So 25 years, 30 years back, so we used to have, I would say, a physical server with very less capacity. So capacity constraint was there. So we used to have somewhere around what I can say, like maybe two CPU with memory of 4 GB or 8 GB. So this is something which I'm talking about 30 years back, or at least 25 years back. We had very small physical servers. We used to have very less capacity for your operating system, disk, and so on. And on this particular system, if we are running a single application, it's not a big loss for the business or for the investment, whatever they are doing. So we used to go and install the operating system. So either it is Windows or Linux. So for your operating system, we used to have a kind of capacity that is needed for your OS, and the remaining capacity can be leveraged across different application that is running on that server. So generally your CPU, memory, the disk capacity, the network speed, so all those things are pretty much very less at that time. So we used to get maybe 40 GB disks, and then the network used to be 1 gig, something like that. And I'm talking about this is also on higher numbers, okay, 30 years back. So at that time, it was not a big problem. And if the organization want to run some 100 applications, what they generally do is they used to have maybe hundreds of servers, physical servers. And obviously we need as many number of switches for LAN connection. We need to have routers for WAN connection, and so on. So this used to be the scenario before. If it is 100 application, maybe if you want to have multiple different environments, so production and non-production, we might have to have multiple servers. So it will be hundreds of servers. It will not be just 100 server exactly, because we might also need supporting utility servers like your DNS, Active Directory, DSCP, and other utility servers will be needed for your environment. So the technology started evolving. Okay, the physical servers started coming up with more capacity, right? So capacity started growing, and the consumption of the internet was evolving, right? So internet was kind of evolving. That means like you are starting to get more speed, more users coming to the internet for accessing services. And obviously the hardware technology also evolved a lot. We started getting new technology disks with higher capacity, and also new technology network interface cards and technologies. And at that time, even 50 years back, 60 years back, we did have this virtualization concept. Okay, so virtualization was available even before 50 years with IBM mainframe, or with other systems, where we used to have one big hardware where we used to create compartments or different application used to be created, co-located or co-hosted on the single hardware. But then it was not, this particular technology was only available in specific hardware, specific operating system, specific vendor product. It was not available for general public usage. So then came the concept of virtualization. So we started creating virtual server, virtual machines. So now we also call virtual instance for your system. So this started 25 years back, where VMware came up with an idea. So initially they started with something called VMware Server, and then they had something called GSX. Then we had something called ESX and ESXi, and now it is a big brand product which is available in, I mean, which is used almost in every single company. At least 98% of the Fortune 100, Fortune 500 companies are using VMware technologies. Either it is server virtualization or storage virtualization. They are using the VMware suite of products these days. So since hardware platform evolved, we started getting very big size hardware. And if you are running one application on a big size hardware, it is going to be a very big loss for the company, whoever is investing on that. See, the reason we were not allowed to run multiple application on the same physical hardware is that if one application needs changes or if one application need maintenance, we might have to bring the other applications also down. So without virtualization, so if it is one physical server with multiple application, so we had that challenge. Okay, so if we are having multiple apps on single hardware, then maintenance and management will be a challenge, because our dependencies is a challenge there, because we cannot install different versions for different application as a prerequisite. So we used to have such challenges. Now with virtualization, fast forward few years, we have this virtualization where we can go and have multiple VMs running on the same physical hardware. So earlier, for having hundreds of application, we need hundreds of servers, right? So now after VMware came up with the virtualization technology, so what they gave as a product, it is nothing but hardware abstraction. See, for an operating system to run the Microsoft or any operating system, so it has some specific requirement. So it needs some CPU, some memory, and it needs some dedicated BIOS, and it needs some dedicated network interface card to communicate on the network, and so on. So what this VMware product did is it gave a kind of abstraction where you can share the same physical hardware resources, like CPU, memory, across multiple different virtual machines. So they did a hardware abstraction. So one single hardware can be compartmentalized and it can be shared across multiple different operating systems or multiple different servers. But before that, if you, in case you want to have multiple different flavors of operating system in the physical server environment, so what we generally do is we used to have a dual boot concept, where we will have Linux or Windows installed, and we'll be able to use only one operating system at a time. So we have to power down one operating system and bring the other one up. Whereas here, you can run multiple different flavors of OS at the same time. It can be Windows, or it can be Linux, or it can be your 32-bit or 64-bit. So you can have combination of operating systems in your virtual VM, right? So here in physical server, you need a same kind of x86 hardware or a 64-bit hardware in order to run their specific operating system. So irrespective of the hardware, you will be still allowed to run 32-bit OS or 64-bit OS on a physical hardware on top of the VMware virtualization technology. So as part of the hardware abstraction that VMware brought in, so you are for 100 applications, okay, what has happened is instead of having 100 physical servers, we just need 10 physical servers for running 100 different applications. So each server can approximately hold up to 8 or 10, or even if the hardware size is huge, so you can have a very big number of virtual machines running on the same hardware. So this is what has happened as part of the hardware abstraction. So hardware abstraction reduced the number of physical hardware in the physical data center. Thereby, the number of physical servers needed for running hundreds of applications has significantly reduced. And the 10 physical servers, we need, for example, for this hundreds of physical servers, we need at least 5 or up to 10 network switches, okay, approximately. And here I would say switches might be 2 or 3 is enough, right? 2 or 3 switches is enough. And the underlying cabling connections, or the racks that is needed. So here we need at least 10 racks. So here we need just 2 racks. So I mean, you can exponentially reduce the count. Let's say 1,000 application, it needs 1,000 servers, and similarly you can compare the quantity in a larger way. But I'm just taking a small quantity to make understand the concept here. So we just need very few racks, very few number of cabling connections for 10 physical servers. So even the power consumption, what we have will be significantly reduced, and the cooling infrastructure that is needed to cool 100 servers will be very high, and the heat that is coming out of only 10 servers, we can manage it with a very less number of cooling infrastructure. So power, cabling, cooling infrastructure, the power consumption as such will gradually reduce. And not just that, so we are able to reduce the number of storage connections that is needed, SAN connections, and we had a lot of benefits here. So with hardware abstraction, we were able to reduce the number of physical server, okay, reduce the physical infrastructure. So we were able to have a lot of advantages. So this is the biggest advantage we got out of virtualization. So this is the big green here. So whereas on the other side, the manpower needed also reduced exponentially based on the number of physical servers, number of switches. We need to have very less number of data center maintenance team because it has reduced or shrinked 1/10 of the size. So instead of having, I would say 4 or 5 engineers or 10 engineers for managing the data center, we just need 2 or 3 people in a round robin shift to manage the data center environment. So manpower reduced. So what did not change is the use the operating systems, the OS. Okay, so virtualization did not reduce the operating system that is needed. So that is the biggest challenge we had. So with virtualization, the physical infrastructure got reduced, the manpower came down, the on-premises physical data center size shrunk by 1/10. So the data center size itself, the data center capacity, uh, I would say the capacity, the floor space, so everything, you need a very small size data center real estate to run this few couple of servers. You need a very small room, and you can run these number of physical servers, and you can manage it within a small room instead of having a very large data center. So here, for running 100 applications, we need at least hundreds of operating system. It can be a combination of Linux or Windows or whatever. So here again we still had hundreds of OS, Linux or Windows on the virtual machine. So here we used to install on a physical server. Later, after virtualization, we still need hundreds of OS and hundreds of operating system licenses are needed, and we need to manage it. And then we need to do the OS management, patching, monitoring, upgrade, maintenance, right? This remained the same like your earlier 30 years back. Whatever we had as a challenge, that still continue to remain the same. But virtualization it not only reduce the physical footprint, that is the primary advantage that we got. So it completely reduced the physical footprint, and also it made the operations, it simplified the operations, I would say. Okay, so it simplified the way how we do operations, simplified the operations activities. So in a way, I will explain a little bit here. See, earlier, if you want to make a clone, you need special tools to clone here. Special tool sets were needed for cloning, for taking backup, or for taking a snapshot, or I would say for moving or migrating the systems. You need special tools. But now with virtualization, VMs are nothing but a folder, a set of files, right? It's a set of files, is what we call it as virtual machines. Our virtual machine is a group of files, a folder. It is very easy to clone. We have snapshot, we can move it, we can migrate it. If one physical server is experiencing issue, if you have that set of files, the vmdk files or the vhd files, that is for your operating system and your application, you can create a new server very easily. It is very easy to migrate or move. I would say portability become much easier. You don't need any separate tools to migrate your VM or to move your VM from if there is an outage. So like for doing all these things, even a system administrator can manage the entire show. So he can do a P2V or V2V, physical to virtualization. They had some easier tools like VMware Converter or Microsoft Converter tools were there. So we were able to easily migrate or clone. Even you can move from one virtualization technology to other virtualization technology very easily. And one more problem with the virtualization era is that we had to pay additional cost for VMware products were little expensive. Okay, some people will say it is highly expensive. So if in case you have VMware vCenter or the vSphere licenses or the other whatever products we are using like vSAN, NSX, or whatever virtualization products we are using, so all those licenses were costlier. So we have to purchase those for management, and even we have to take care of the upgrades, maintenance of your virtual infrastructure. So that actually added one more complexity. So there are two major things. So if you need a remote team for managing this hundreds of OS, hundreds of physical server, so the remote team size was earlier, I would say, maybe something like 20 team members were needed, 20 engineers, because like we had remotely we need to manage at least 100 physical servers and hundreds of operating system. So maybe I would say considering 1 is to 100 ratio, so generally we do a KPI, right? So one engineer is needed for managing 100 servers or 100 operating systems. So roughly we used to have a remote team of 20 engineers, but then in the virtualization case, yeah, it did reduce some significant number of engineers. Like maybe I would say instead of 20, we had 10 engineers who can manage the remote physical hardware, because the number of hardware significantly reduced, and the number of networking devices, instead of having 4 network engineers, we just need 2 network engineers, and so on. Even similarly, storage engineer requirement came down. So instead of having 20 engineers, we just had 10 engineers, but the number of operating system that we need to manage remotely, that remain the same. Okay, we need to manage the 100 plus operating systems remotely. We need to log into them, patch them on a monthly basis or a frequent basis. We need to take care of the antivirus, patching, vulnerability management, monitoring of those tools, everything. Okay, so those activities still remain the same. So we still had the remote administration team. It did reduce, but then not to a very larger extent, because we need, as a system administration, we need to do a lot of server operating system management at the virtual level. So this is one of the challenge that we had with virtualization. But additionally, we also got better isolation because see, if you look at each of the virtual machine, VM does have its own separate BIOS. It did have its own. You can have a separate kernel. You can have a separate set of logical hardware or logical devices. So it did provide isolation. Okay, so there was some isolation. You can have VM, it even though it is portable, even though it is flexible. So we did have isolation at the VM level. So it had a independent operating system, independent OS, independent drivers, and whatever we need at the as a prerequisite for your application. They did have segregation at the OS level. So OS level isolation or segregation was there, so which did provide some level of additional security, and it was much easier. And the deployment time, okay, so to create or to restart the VMs, so deployment, the restart of VM, definitely it reduced the time. So instead of restarting the entire physical server, we just need to restart the virtual machine. So to restart physical server and physical operating system, it needs its own quality of time, right? Maybe we have to wait for 15 minutes or 10 to 15 minutes for restarting a physical server, whereas your virtual machine can restart in a matter of 2 to 3 minutes. So definitely the downtime, the maintenance window started getting better in virtualization. Since the VM can boot in minutes, here it at least says it boots in I would say, yeah, minutes only. Okay, 5-10 minutes or 10 minutes, 10 to 15 minutes maximum. Whereas here it boots in seconds. I would say 3 to 4 minutes maximum. Right, that's how it takes. The booting time reduced and the performance got better because we had a very large evolution in terms of the SSD technology in the disk. We got better network speed, networking devices. So hardware virtualization also uh, was successful because the hardware vendor, like the Intel manufacturer processors of or AMD processor, they also started coming up with support for virtualization technology, and also it came up with some functionality at the hardware level, which can do better caching and better functioning of your VMs. So resources can be managed in a much better way at the hypervisor level. There was one particular caveat at that time was heavily discussed, but then we were not able to have a very big significant difference. So at that time, people were saying the virtual machine doesn't have uh, direct hardware access, which actually limits its performance, and all those things was a claim at that time. But when we did a benchmarking test, okay, definitely physical hardware, it gave much better performance, and it was a very good it gave very good speed and stuff. But compared to physical server performance, obviously virtual machine was a little slower, but application owners or the business owners were happy with what they are getting, and they were able to run their application and provide it. So it was a mature technology because it had all significant significant security measures or models in place. So that's the reason the business owner were very happy with the virtualization technology, and they had this easier option to roll back with snapshot technology. They were able to create templates. They were able to create, I would say, what is that, images, snapshots. So these options were mostly needed by the business owners. Earlier with physical servers, if in case you want to create a template or image, yeah, it is very very tough. Okay, it's not that easy. You can take an image, but you need a third party tool to go and create a physical entire image. But nowadays, even within the basic virtualization hypervisor level, you can go and create a template, and you can store it in a content library, and you can recreate systems very quickly. So there are a lot of flavors that are available. So VMware is the popular one. That's the reason I was giving an example of VMware. But VMware has vSphere, and Microsoft has got Hyper-V, and Linux has got kernel virtual machine. Amazon has got Nitro hypervisor. There is Zen hypervisor, Promox. So there are a lot of hundreds of products even available in your virtualization, and there are multiple types of virtualization, that is the type 1, type 2, but it is not much needed for here. So virtualization allowed you to run multiple virtual machines on one single physical hardware. That's the takeaway here. So now, after all these things, we have to get into containerization, right? So currently, we have this containers. That is the way we are currently running our applications, or business applications are currently running on containerized platform. So this is the current stuff. So with containers, this is a little different technology. It's a OS level abstraction instead of hardware level abstraction. So the challenge what we had is we did not reduce the operating system. So the business was looking for a way that can reduce the number of operating system needed for your business to operate your business. So this came in, the containerization concept came in, and then it did provide that OS level abstraction or OS level virtualization instead of hardware level virtualization. Virtualization is what? It is making the operating system feel like it has got its own independent BIOS, it has got its own independent CPU, memory, and stuff. So we are making the operating system believe that it has got its own environment. But in reality, it did not have a separate physical server to run it. So we were able to establish that, and it has been running in the environment for more than 20 years without there were some challenges at the beginning, but later a lot of things have got rectified. So containers is a way that we can do a OS level abstraction. So instead of having hundreds of operating system for your containerized environment, we just need only 10 or only tens of operating system. I would say only 10 operating system is needed for running 100 containers, or even more than that. So it is like you have containerization technology that is supported on Linux and Windows. Even it is supported on Mac operating system also. But in production, mostly it is Linux, and in some cases even you can run it on Windows platform also. So you just need only 10 operating system to run hundreds of container. So container is nothing but a package. It's a software package um, for your application. It's a software package, or I could say it's a logical box or a folder within which has everything for your apps to run. Okay, so what are the software package will contain? The software package will contain the operating system, the application code, the runtime, the system tools, library files, etc. So even the operating system related, OS related files will be, if the application needs separate OS specific files or stuff, then all those things will be contained in that software package. So in this containerization era, Docker was one of the most successful product compared to the other products that we have. So we did have a lot of other products which was competitive enough, but they were not very successful in the market. Okay, so I would list few for your reference. So Docker is one of the technology where we were able to create software packages and run it as a container. So we also had Linux LXC, LXD. So some technologies like LXC and all, it came before Docker. So I would say LXC, Linux containers were available since 2006 or 7, whereas Docker started getting popular only after 2013-14. So these products were available even before Docker came in. So how these people got the market, I'll explain how these people got into the market. There are many different stuffs. I don't want to list everything. See, as I told at the beginning of the session, if IBM had expanded their technology, the virtualization technology towards maybe x86 hardware or the 64-bit, yeah, the 64-bit hardware. Okay, so if IBM has expanded their technology towards x86 hardware, then a lot of IT companies might not have come into the picture. Only we might have had companies like IBM, HP, or a few more companies. But nowadays, you see Amazon, you see Google, and a lot of modern companies, because like IBM did not expand their technologies into x86 platform, but then VMware took that opportunity and then they invented the same virtualization concept for x86 hardware, which is where most of the business application were running. So IBM was not the only company which was providing the technology for running the business application. We had competitors at that time like HP or Dell or many other companies were there. So they were also providing some hardware technologies and which can run operating systems and so on. But IBM had the virtualization concept even before all these operating systems were introduced. So if IBM had expanded their concept towards x86 platform hardware, then they might have been a monopoly company in everything that we see now. But then they missed that opportunity. So VMware made best use of the opportunity to expand their technology in to expand or to provide this unique feature of virtualization to be available in x86 hardware. Similarly, there were very different technologies that were available specific to specific hardware and operating system, but Docker came up with an option where it can be used very easily. They came up with both server side and what you call a graphical option as well as a command line option, similar to VMware, where they had a lot of user friendly options. See, before ESX I came in, this particular era, before that what they did is, in order for the end users or the system administration to become familiar, ESX was more like a Linux operating system, like a Red Hat operating system. So it was more user friendly. You can log into operating system, you can do a lot of different things, you can install a lot of services, packages and stuff. But uh, that was good for a lot of system administration to learn the technology. But on the other side, for the business, if you are doing a lot of changes, you are making a lot of changes, the system will not be stable. So if you are making upgrading the packages or changing the drivers, or if you're doing a lot of work on the hardware or the operating system, then there are more chances that it is prone for failures, it is prone for a lot of downtime. So what VMware did is they created a specialized operating system. They call it as a hypervisor. So that hypervisor is a purpose built operating system for doing the virtualization concept. So it is a virtualization operating system. So this particular, I mean, even GSX and ESX were called as virtualization operating system, but ESXi was a purpose-built operating system for only doing the virtualization functionality. So you cannot install other features like FTP or NTP or other services. Whereas this ESX and the other products which we had earlier, a lot of other services and stuffs can coexist on the hypervisor, and it really created a problem for the business. But for the system administrators, they were able to learn the technology, they were able to do a lot of use cases, and they tried a lot of things in ESX, and that was the reason it was very popular. Similarly, Docker had given a lot of options. Like they came up with a GUI tool that can be installed on Windows. Parallelly, they came with a command line based Docker tool which runs on your Linux operating system. So it was more user friendly. It was very easy for the people to learn the technology, and it got very popular. Okay, and then now there are a lot of other providers or specific vendors providing their own features. Like today we are discussing about Microsoft Azure, right? So Azure provides Azure Container Instance, which is based out of the Docker technology or the Docker solution, which now become Azure Container Instances or Azure Container Services, which runs the instances or containers within that platform. So it evolved from the Docker technology. A lot of different vendors, they took the product and some of the open source code, and then they modified and they are giving it as a service. So in containers, we have the libraries, the script, the dependency files. All those stuffs will be packaged into one particular folder, the dependencies that is needed, or the scripts. So all these things, the developer will create the software package which will contain all the necessary stuffs for your application to run. It will not have anything that is not really needed. See, if you take your virtual machine, there will be lot of different services, lot of different packages, lot of different stuffs which will be installed and made available on your operating system. But ideally for your application, it only needs a set of prerequisite. See, for example, if you go and read the application prerequisite, it will just say I need only .NET framework and a few amount of CPU memory and all those things. But in reality, the virtual machine will have too many number of program files, too many number of services running on that server, which is overloading your operating system and so on. So that was a big challenge. So you need a separate space for your OS drive, OS partition, and you will get only remaining CPU memory and the disk space for running your application and data. So your OS was consuming a big chunk of size. So, operating system OS was consuming fair bit of disk, CPU, and memory cycle for running its operating system. But ideally here, with software packages, we just have very small amount of dependency files created. And here, the segregation is not at the VM level or OS level. So that is a kind of a problem here. So I would say where exactly we mentioned that point. So easy to clone, upgrade, fix. Yeah, so here segregation is at the application level. So your applications will coexist on the same operating system. So you'll have only um, very few number of operating system that you need to manage. So here, instead of having 10 hundreds of operating system, we have only 10 operating system. It's easy to manage, patch, or whatever the operational activities that we do. It has got significantly reduced in containerization. We just need a very less number of servers, and obviously when you have 10 operating system, the licenses cost reduced, and also we reduce the VMware vSphere cost. Okay, that is the biggest advantage, I would say. And you don't have to really see if you are creating 10 different or 100 virtual machine. So how much size you need? So for example, let's say 100 VM. So if it has 100 operating system, so for each of your operating system, let's say on an average you need 20 GB. So Windows might need more space and Linux might have less space. So let's say on an average you need 20 GB. So in your data center, just for your operating system alone, you are spending more than 2 terabytes of capacity just for your OS content. All those are redundant contents. So every single server will have the same exact program file, same exact OS related content, and so on. It consumed a lot of disk capacity. Not just that, even in every single physical hardware, maybe I would say 40% of the capacity was consumed by your operating system requirement. The CPU, memory, disk will be like every single hardware we're having 40% wastages. So here in containerization, we are not giving separate space for each and every virtual machine, because we don't have separate operating system here for each of your software package. It shares the single kernel, right? So it shares single kernel, and it shares the operating system for running multiple different containers, and also one operating system for one big size hardware. Okay, one physical hardware. So number of hardware will be exactly equivalent to the number of VMs that we have. And mostly like the segregation is at the application level, right? So your processes, your services are different from one another. So it is much easier. So the booting time will be in very few seconds. So it boots in 10 to 15 seconds, the containers. And it is very lightweight. The consumption is very less. very lightweight. So I would say the data center size has even further decreased in terms of disk capacity, and you don't have to really have um, as many number of disk capacity, CPU, and memory. It has significantly reduced, and you also have direct access to the physical hardware through the operating system. So we don't have a virtualization hypervisor layer. So your applications are directly running on the base OS, base operating system, and you have direct access. And it's a kind of we can easily clone it, recreate it. So all these things are pretty much available even here. So it is easy to clone, easy to migrate. Sorry, it is easy to clone. It is very portable, even much better portable than virtualization. And it also had a lot of native performance. Okay, what current business need is the agile way of delivering things, agile way of updating your system. So that is what container is helping you out. So if you want to bring agility or speed to your business, so container is what is the solution where you can quickly update your services or any specific module. So if you log into one of your website, see earlier, generally during the virtualization time, we used to have separate system. See, let's say if you are talking about Amazon or Flipkart. So let's say Flipkart. Let's not take Amazon as an example here. See, if you log into Flipkart, a few years back, maybe 20 years back, what they used to have is they used to have the entire web application in a one particular layer. So in during the virtualization time, so we used to have a three-tier or multi-tiered approach for running your application. So we used to have a web layer, we used to have an app layer, we used to have a middleware layer for integration, and we used to have a database layer where we used to have the actual data stored. But now all these things have become the web itself, the web front end or the application has become has got split into multiple small apps, or I would say services or processes, and it can run independently as a small container. So instead of the web server, app server, it needs its own independent VM. So here the microservices, whatever we are creating, it needs its own independent container. Okay, only that much. So here, if you take this particular portal as an example, so this login procedure, the cart management, the product listing, the integration with third party banking sector, so all these things can be split into multiple different small microservices. So each and everything can be a small application. So your login procedure can be a small microservice, your cart management, your vendor management, your banking integration, your chat management, your remarks or feedback management, everything can be a separate small application. And if in case you want to make some changes to the product listing, you don't have to bring the other things down. So other login procedure will continue to work, people who are adding something to the cart will continue to work, so the banking integration will still work, the payments will still be working. So for few seconds the listing will not be available, and that will be very seamless for the end users, because the background application, the overarching application will still be available. Only that specific module or the specific microservice will not be available during the maintenance. See, earlier we used to have, I'll just give you an example. So shopping cart microservice. So if you go here, see, instead of either like before, when the end user want to log in, they will have all these entire thing in a single server. Okay, so if you take this example, so your catalog management, your shopping management, the returns management, payment management, so all these things will be put into a single server, where if you want to make any changes to any of this particular stuff, you need to bring the entire application server down. But now each of your different modules, like the ordering, the cart management, the login management, it can be an independent microservice with its own independent database. So you can have a for catalog listing, if you want to see use a document DB or a graph database, it will be much easier to have a separate database here. And for discount management, if you want to use a NoSQL database, and for shopping cart, if you want to use a SQL database, you can have its own independent databases for each of your microservice. That is another big thing here. So each microservice or container can have its own database, and it can be a combination of SQL or NoSQL or whatever it needs. Even you can have an access DB which can store your content. So your big application, your big monolithic application has become a small microservice. And if in case you need, if the developer says I want to make some changes to my catalog, only the catalog will not be available. The remaining discount management, order management, shopping cart management will be still available. See, that is just an example, but if you just really go into a shopping thing, so you will have even much more stuff. So cart management, service management, shipping management, inventory management, product recommendation management. See, whatever way you can split your application, you can keep splitting it. See, if you take an example of Netflix has got, you will just see one particular website or one particular application portal, but in reality Netflix has thousands of containers running on the back end. See, if I just go and say Netflix number of containers or microservices, it will have thousands of microservices in the, see, over 1 million containers are being used within your Netflix application. It might look like one application for you, but then behind the scenes, for every small module that you have in your application, Netflix or Flipkart or whatever, behind the scenes it is hundreds of container that is servicing or providing your stuff. So you can also go through this. It's not a big thing that you need to remember. So a lot of different technologies, a lot of different companies are using hundreds of containers to run one single application, and only that specific small module will get downtime if the developer is bringing updates to that product, right? So let me close this. See, the login procedure, the discovery management, the file streaming, everything will be put into different. So Netflix is running on Amazon cloud, so we don't have to take that here. We are discussing about Azure. So a lot of different customers are using Azure services to run their shopping application. Shopping application is one such example. This particular containerization has been vastly used in automobile manufacturing, even in healthcare industry these days. Many banking, banking, and even a lot of government agencies have started running their application in a containerized platform. So it gives you native performance, and it gives you lot of easy way to make redundancy. You can clone it, you can use the DevOps integration. So it is very easy to deploy new updates using CI/CD pipeline. So those are all something which has brought in a lot of advantages. So the DevOps integration is one advantage, and then we have direct access to the physical hardware. That is another one. And here, the biggest advantage with containerization, we reduce the OS footprint and the hardware footprint. Okay, so here, reduced the OS and hardware footprint by 1/10. Okay, so instead of managing 100 operating system remotely, we just need to manage only 10 operating system, and that too, it might be a very stable Linux operating system, or even sometimes you might, if you're running Windows container, it will be 10 Windows system instead of 100 Windows server. So this is another biggest advantage with operating system abstraction. You can run hundreds of container in the same single physical server. If you are running 10 virtual machines on, let's say, if one physical server is running 10 VMs here, So here in one physical server, we can run at least 25 containers. So that's the level of advantage you get. Okay, so that means obviously the number of hardware resources that is needed has significantly reduced, even more than one tenth. And that's the reason we are currently using containerization and DevOps for deploying, creating, and deploying your application. So all the businesses are moving towards uh, containerized based application development and deployment. So let's see some demo on how you can create it. As I told you in the morning, so we need at least 10 to 15 hours to learn the entire Docker procedure. It is already available open on how to install Docker on Linux, how to install Docker on Windows, and how to create Dockerized containers on your native operating system. But here in Azure, we have an option called Azure Container Instance. So that is what we are going to see in details. Okay, so Azure Container Instance, or we can call it as ACI in short. Okay, just maybe in the interest of